Why don't we go ahead and get started? Hi, Walt McGuire again. It's a little bit past 10 a.m. Mountain, and we're going to go ahead and start the webinar now. Thank you for joining today. We're happy to have you here. This webinar is going to focus on a game changer for attack surface management. We call it ASM++, and we're going to show you how you can find and fix some very high value hidden vulnerabilities you don't know exist in your enterprise. Before I begin, a word about the name. As we built this, we talked a lot about the capabilities it brings, and we felt like it's analogous to the difference between C and C++. For those of you who know software development, C is a great language. There are applications all over the world still using it today. But a while ago, C++ came along. It was a game changer for software development. It really raised the game. ASM++, this joint solution we have built with ThreatWorx, is a game changer for attack surface management. So we're very excited about this. We're very excited to tell you about it today. Before I begin, a word of thanks. So ThreatWorx has worked with us on this to build this, and thank you for all the hard work, Ketan and team. And Atlas, the Atlas group, has helped bring all this together and introduce folks. So thank you very much to Robbie and team for helping us do that. So let's go ahead and get started, shall we? So you're all literate. I'm sure you can read the slide, so I'm not going to read it to you, but we wanted to begin by laying some groundwork for what we're going to discuss. So attack surface management today is the continuous practice of identifying and mapping threats and exploits to your assets and presenting that in ways that your security folks can understand and analyze. There's a lot of competence in the field. There are a lot of solutions in the field. There are some gaps, and we're going to talk about those gaps a bit, and we're going to talk about how our solution addresses those gaps. Let's begin with a concrete example. So F5, recently, by recently, I mean, we could mean in the last few years, devices worldwide were breached by a nation state actor. And maybe the more frightening subtitle is it went undetected for at least a year. So the breach happened, and they didn't know it for a long time. And what it means is, first of all, their source code was stolen. For anyone in software, those are your crown jewels. So somebody now owns their source code. But maybe more impactful to the world is over 600,000 host systems were placed at risk because of that breach. And the impact to F5 was the shareholders collectively lost at least $1.3 billion. So massive breach, massive problem. And when we look more closely at it, we learned some kind of disturbing details. We learned that the vulnerability and malware were both well known before it happened. So this could have been prevented. And the question we all ask ourselves, and this was in our minds as we built this joint solution, is why didn't F5 spot the risk before the breach? How and why did the breach go on for as long as it did? So we're gonna show you how we can address that. Let's talk about ASM++ in a bit more detail on what it means. It's going to allow you to identify assets at risk before breaches happen. And this combines the power of the ThreatWorx attack surface management solution with the Rocketgraph graph analytics platform. And it does some things that simply weren't possible before. More specifically, this is going to bring some new capabilities to your attack surface management practice. By that, I mean, you can look at a very comprehensive blast radius analysis. We have some challenges with attack surface management today, and that limits your ability to identify the real blast radius. David's going to show you a way of visualizing and understanding this that's going to bring that home, make that point. But also you can look at multi-hop attack paths. So very rarely does a bad actor take advantage of a single exploit to get all the things done, to steal the source code, to steal the money, to bring the systems down. They usually use one breach to get in, and then they take multiple hops and multiple attack paths and take advantage of multiple vulnerabilities across assets to do the damage, to get the doors opened. That's the part that usually is a struggle. It's hard to map that and show those relationships. So ASM is unique in that it provides organizations that connected intelligence. And maybe even more compelling is Rocketgraph has built an AI-first user experience. That means that you don't need to write cipher queries. You don't need to be a graph expert. You can sit down at the console and you can ask a question. a question in natural language, and we will leverage artificial intelligence to get you cipher and to recommend a path of analysis for you. And you're going to see that in David's demo. And because of the way we built Rocketgraph and because of the way Ketan and team built ThreatWorx, it's very easy to add new information. That's going to be increasingly relevant because enterprises don't just run on their servers. They have a lot of other things. So today's agenda, what we're going to do today. I'm going to introduce our two speakers, very accomplished folks, very smart folks, very deep in their respective fields. We're going to talk a little more specifically about ASM++, what our mind map is for how to represent it. It's laying the groundwork for you when David shows the visualization so you can understand what you're seeing. David and Ketan are going to demonstrate. So Ketan's going to show you the ThreatWorx solution. He's going to talk through that with you and show it to you. Then we're going to hand it to David, and David's going to work his magic, and he's going to show you ASM++. So how these two things come together to produce a very unique option, a very unique set of value for enterprises. And now we're going to have Q&A at the end. I have a comment about that. Right now, Q&A is live, so you can ask questions. What we're going to do is we have a number of our colleagues from both organizations on this call on mute. If the question is a straightforward one, what's your website, what's your favorite color, and so on, our panelists will answer those questions for you. If the questions are more thorny, if they're deeper and they require more insight, more discussion, what we're going to do at the end is we have time carved out so that Lisa, our CMO, is going to identify those questions, look through them. When we're done with the demos and I've got a little more material to present, we're actually going to go through and we're going to have a conversation. Lisa's going to ask the questions and we'll be able to let our experts discuss and express ideas and opinions on how this goes forward. And then we've got some closing information and call to action to help move it forward. So without any further ado, let's go ahead and move on. Today's speakers, David Haglin, PhD. David is a co-founder and CTO of Rocketgraph. His expertise, it brings together academia as well as hands-on software development experience in two very interesting and interrelated domains, high-performance compute and graph. Graph is great. High-performance compute takes graph and means you can look at not just a segment of your graph, but all of it. David has over 25 years of experience in both of these domains, and he's a thought leader in his field. So he's got over 60 scientific publications. Ketan is co-founder and CEO of ThreatWorx, which is a next-generation cybersecurity platform that solves a bunch of existing problems in the attack surface management practice. Ketan has over 20 years in software development and very deep expertise in networking and storage architecture and design. So I want to extend a thanks to our speakers. They've been working tirelessly for a long time to make this happen for everyone today. So we're recording this and we're very excited to have them present. Let's talk about the mental model for a moment and how we've assembled this information today. If we look at how we represent threats in the enterprise, we look at, there's a relationship, an asset. I may have a server, and the server may or may not have a particular vulnerability. And there may be malware which exploits that vulnerability. And there may be threats that are going to drive all those things. And so the way we map this is we're going to draw a diagram that's going to show you how these things interrelate and across your business, how assets can be at risk based on different exploits, different attack paths. Part of the background here is that ASM++ was necessary because today threat detection is piecemeal across attack surfaces. There are a lot of point scanners. They find and address one particular area of your threat surface, but they don't speak to each other. What we really need is we need to be able to put that information together, and we need to be able to map it in a graph. ASM++ allows you to take that once we know those relationships, and we can detect, prioritize, and apply context to the threats across your entire attack surface. You're not looking at part of it, you're looking at all of it. Once you can do that, you can identify and highlight and prioritize all the paths attackers could exploit once inside your network. So if you think back to F5, F5 could have taken this, they could have looked at that, they could have seen that exploit, seen the level of risk, they could have prioritized it and patched it before that breach. What this also means is it means you can find things you didn't know about. So you'll see things you didn't know existed. So I'm going to hand it over to Ketan and David now, and they're going to demonstrate their respective solutions for you. So Ketan and David, please go ahead and show all the great stuff.
Well, thank you, Walt. Hello, everyone. Thank you for joining us today. My name is Ketan. I'm the CEO and co-founder of Threatworx. I'm excited to show you the Threatworx and Rocketgraph combination that together can uncover these hidden threats and also help prioritize them for you and put them in the right context, just like you have asked today in the poll. And those are the kind of threats that would lead us to the kind of breaches that happened recently at F5. Now, just a quick disclaimer here, the F5 breach is still under investigation. Information is trickling out. We don't know exactly how the breach manifested within the F5 networks. We have some details about that. But this is in context of what happened at F5, not necessarily exactly trying to explain what really happened. With that, we can jump in, and I'm going to share my ThreatWorks console here. From what we know, I mean, the information that we have right now, the attack was used the Brickstorm malware, which is a nation state actor that was using this kind of a malware in large parts of the actual attack. The malware was known to us for a long time, and the good news is that ThreatWorks was actually tracking this malware for a couple of years now, more than a year now. So we've had information about all the weaponized vulnerabilities, the IOCs, and all the information about this malware as it was evolving. We have a threat and vulnerability curation platform which is doing that
Ketan, I
automatically.
have a question for you, and I want to verify this.
Yes, please.
I'm seeing my slide, the demonstration slide live. Are you sharing your screen at this point?
I am.
Okay, so let me stop sharing because there we go. Okay, I think that's fine for attendees. I'm new to Zoom, so if anybody can't see Ketan's screen, please post it in the Q&A so we can address it. Okay, thank you. Sorry, go ahead, Ketan.
All right. So the good news, as I said, is that we have been tracking this information for some time now. We know a lot about the related malware families that could have been used in conjunction of Brickstorm. So we have all this information laid out for us. And as you will see in the in David's demo, this information needs to be put in the right context and prioritized. We do some of that as well in the platform, but you'll see what the difference that the graph solution brings for us here. So now that we know the background, the sort of the context of where this breach might have started, let's look at the entry point. And again, based on the information that is available out there, this is attributed to a couple of vulnerabilities that affected not just the big five F5 big IP WAFs, but also some VPN servers, the Ivanti VPN servers. So we have been tracking a couple of those VPN servers with the software that they have with the patch levels that they have out here in the platform. As you can see here, we have identified vulnerabilities on them, and we have been tracking them for a while. And those vulnerabilities are still there. I mean, unless you've patched them, unless the patches are available for you, those vulnerabilities we suspect were the entry points for this. So the platform is able again to detect. This is the scanner. This is the universal scanner that we have as part of the platform, which is able to not only discover, scan, but also prioritize and give you information about potential patches and remediations that might be there. So let's look at a particular example of a vulnerability that was used or was part of this whole attack. And it's again specific to Ivanti, the VPN. But again, the platform that we have, the threat and vulnerability curation, was able to not only assess the CVSS score in real time as this information is surfaced, but also do the equivalent of EPSS or exploit prediction or a weaponization prediction. And it was I mean, very early predicted that this vulnerability could have been used as part of a weaponized malware, right? So all those things are important in to sort of set the right context, set the right risk level, set the right priority for such high impact vulnerabilities. However, what we see is that our manual efforts of identifying and assigning CVS score, just basic stuff like CVS score, is quite lagging. Now, this is the same vulnerability and the vulnerability record in NVD, and you can see here that NVIDIA is yet to assign a CVS score to it. And this happens because this is all a manual process, and that's where the AI behind ThreatWorks is important for us to be able to do this as close to real time as possible. So we can't depend on human effort because this is kind of a unscalable problem. We know this now much better than we did before. So we need the ability, we need AI to be, deployed at the right places, and the platform is doing that in order to, sort of put the right context around these high value vulnerabilities. Now, we'll just dive in a little bit more into the specific vulnerability. The next thing that we need is to be able to put an action behind this, and that is again something that the ThreatWorks platform is able to do for you. It is able not only to assign the CVS score and predict the EPS scores and everything. It is also able to give you recommendations on what to do about it. Right? This is again the Gen AI part of the platform, which is able to generate patch scripts, remediations, if there are any kind of misconfigurations that can, or any workarounds for this vulnerability, those will be scripted out for you and available for deployment. So all of this happens as soon as the information is available for these vulnerabilities on the World Wide Web or elsewhere. And these are the things that give you that edge in terms of being able to remediate these faster. Now, this is this is just one example of a particular vulnerability or a threat that was involved in this. But like we said before, like Walt alluded to before, we need to look at this in the context of the entire attack surface, because this is not just about the VPN servers. This is not just about one point of entry. There could be several. There could be different areas which are less protected or have these high risk vulnerabilities that need attention. And many times this information gets lost in rows upon rows of scan reports, and maybe doesn't get prioritized for patching. We need to be able to do this as close to real time and as early as possible, and with the right information with us, right remediation scripts, right steps to remediate, and so on and so forth. So this is what the platform will be able to present to you. Now we look at a completely different perspective for the same data when it's mapped to a graph. So that's what David will just show you. And really, we are just getting started, right? So now we've identified the entry points, how the attackers could have gotten into the network. Now we'll see how these can be mapped to the hidden paths and their respective blast radii, and we'll know exactly what paths are possible, what the lateral movements the attackers could have taken once they're in the network. Now, there is an assumption here that these these particular assets that we are looking at, are part of the same network. They in fact are, and there is lateral movement possible in terms of network connectivity. So with that, I'm going to hand it over to David, and he'll walk you through the rest of the demo. David?
Sure. Yeah. Just sharing the screen here. I know very little about attack surface management. I've worked in cyber for many, many years, but always inside the network, never right at the surface. So when Ketan and I were starting to figure out how to put these two tools together, I had to learn a lot about the attack surface management. Just as a reminder, what I'm going to show has nothing to do really with the F5 network breach. I'm going to show you what it looks like to be able to take the same information that ThreatWorks was gathering and curating and feeding into a graph and using that graph to help look at the entirety of the surface, the attack surface, from a graph perspective. So we're taking now with a graph, we've got nodes and edges, and we don't really need to know all about graph in order to understand this. But these nodes are really collections of data of similar families. So all the threats, for example, are one node type. They have the same collection of attributes and properties. We've got the malware families here, such as Brickstorm, all the vulnerabilities or the CVEs and the assets. So this demo is going to focus mostly on the first four of these node types. We're not going to be showing the products because what we're going to see, even with only 187 assets, we're going to see a very rich graph structure. So I will move on to that. Rocketgraph was developed at a DOE national lab, and I think I see some people from that lab as attendees of this webinar, so thank you for attending. And it is used by our federal government. Some of the three-letter agencies are using Rocketgraph for really large-scale problems. We can grow large. We can be very effective at smaller scales. What we're going to see in this demo is pretty small. Does this look small to you? This is the attack surface and all of the relationships among the malware families, vulnerabilities. This is pretty rich in structure, right? What we can do is we can kind of explore this a little bit, see, oh gosh, we have assets. See, it's even too big to see where the asset is. Let's just look at, well, let's see. Can we find those blue asset names? These are the two VPN servers among all those 187 assets. They're right here. This is VPN server 2, VPN server 1. What I'm going to do is start doing a path trace from where things are reachable from those VPN servers, assuming that a VPN server is the entry point for some layer 0 or L0 breach. Remember that inverted pyramid? The L0 is the point of entry. L1 would be these one hop away. So we're looking at layer 1 now. Ooh, excuse me. We're looking at the layer 1 vulnerabilities that can be reached, or CVEs. Do we see anything? This is a pretty small part of the whole attack surface. I am touching still only 2 assets out of 181 here that are showing up. Let's go out to layer 2 and back down to the vulnerabilities and then to the asset. And what do we have here? Gosh, just in the layer 2, we're seeing, is that a third of the graph covered already? We have 82 assets that are reachable in layer 2 out of the 181.
So David, this is basically you're exploring the blast radii at these various levels, aren't you?
That is correct. Yeah. Thank you, Ketan, for reminding me. Again, as I'm not an attack surface management person, the term blast radius is, I mean, I understand what it means, but it's not something that is always there, and I use it frequently. But I understand this is the common term in this field. There's this dandelion thing out here. I haven't talked about that. What is this dandelion thing? We're not reaching this in the L2 blast radius, layer level 2. This dandelion is a whole bunch of assets that have a single vulnerability. And it's interesting to see that this vulnerability is a privilege escalation vulnerability with a Windows server uh, or in a Windows cloud system. Um, Now we don't really know what these all are, given what we have in the data, uh, but that's an interesting structure that is really hard to see in rows and columns. Um,
Could
and
this be one of the high value assets, perhaps, David? I mean,
yes, well,
one of the assets where the code repositories might have been for F5, maybe.
certainly source code repositories are high value assets for a software company. And a lot of infrastructure or a lot of enterprises have source code for a lot of what they do. There are also database servers that are high value assets, and it really depends on the enterprise, doesn't it? Um, so
But right now there are no paths to it, as we
Right now,
see.
there are no paths to it.
Okay.
So let's imagine that there's some source code repositories out here and maybe even a database or two,
Mhm.
and it's all safe because it has been relatively isolated. There's only one vulnerability that could affect all of these different assets. But let's go out now to level 3. So I'm going to go to the threat, back
So
to
for the
other.
benefit of our listeners, David, what you're going to do now is you're going to go to that L3, which is going to expand that blast radius. Is that right?
That is correct. This blast radius is going to be much bigger than the 62 nodes we had before. We can
Mhm.
see that in this level 3, we in fact reach this little dandelion. Um, and so all of those are now in the blast radius. Uh, and let's see, what else can we see here of interest? Where does this?
Well, I see that we've got 181 assets total, and we've got 173 at risk if this path is taken for breaches. Am I
Yes,
reading that correctly?
yes, you are reading that correctly.
Wow.
173 of the 181. So we're over
Ouch.
90% of the entire enterprise, of the entire attack surface, reachable within that level 3 blast
And
radius.
and all an attacker has to do is take care of a couple of exploits. That's it.
Yes. Now,
Wow.
prioritize and patch. This is
Yeah.
what's really important. Uh, if your high value assets were sitting over here, understanding that there's one vulnerability there is really important to figure out how to prioritize where you patch. Uh, that's one way of looking at what our product can do. I'm going to show you the AI integration here. So I'm going to give an English description of what I'm looking for because when in this tab, I'm looking at just all of the assets except for these two VPN assets are kind of just all gold. They're all the same, right? So I'm going to ask the question, how do I zero in on or pay more attention to the high value assets? So for this demonstration, I'm simply going to assume that a risk scores above 70 are high value assets. I'm asking about CVEs that affect those assets. And if it's going to be hidden, that is, it's not already exploited, but it could exploit soon, then there's going to be CVEs that affect multiple of the high value assets, but not very many of the malware families are currently exploiting that CVE. So I'll just click on the get cipher. What we're doing now is asking a Gen AI system, in this case Claude Opus 4.5, to generate a cipher query from that prompt that I just gave it. So the query first identifies CVEs that affect multiple. So what we do here is we provide explanation as to what the cipher is doing, and then insights why you want to run this query, what you might learn. The point that I think is really important here, CISOs are not going to want to learn how to write cipher queries. but they want to know how to ask questions of their graph. Here's the question they may ask. Here, and then they say, I want to run that query. What have we got? Well, okay, here's a different view of that graph, but only high value assets. So a much simpler, smaller, cleaner graph. You see the VPNs in here. You see this malware family of Brickstorm. I've highlighted that as yellow. These are the F5. I mean, there you go. With that, I will turn it back to Walt.
Thank you. Caught me talking on mute there for a second, David. Well, thanks for that. I don't know about folks on the call, but I find this interesting stuff. I mean, I've discovered that with just a few exploits, an attacker, a bad actor, can penetrate most of the assets in my business. That's deeply disturbing. But the best part is now with this, I can actually go and fix it. Is that right, Ketan? Do I have that right?
Yeah, that's the next step, isn't it? I mean, okay, we know now. I mean, that's great information to know exactly how bad things are or could get if an attacker manages to get in. But what do we do about it? Now,
Nice.
first of all, since we know most of the attack paths, we have mapped them out based on the information that we have. Maybe it's time to just start prioritizing and fixing them. Now, that's easier said than done because for most of those CVs, you may or may not have patches, may or may not have remediations. I mean, what do you do? Do you just disconnect those assets from the network? That's no good. What can be done again? Threatworx, as we saw, could generate these steps, these remediations steps, download or scripts to download and install those patches at the right places in the context of the actual vulnerability that needs to be patched. So if it's a
Sure.
Windows vulnerability, you could get those patches in your PowerShell scripts or what have you. And you could also get packages of patches that can be deployed across your
That's
network because
great.
there are more than one assets that need to be patched. So all of those things will be ready, will be available at a click on the Threatworx side. All you need is to be able to orchestrate the patches, and that is again something that is very specific to enterprises how they deal with this. But we have a way. The bottom line is we have identified all the paths. We know all the dangerous CVs. We know what their priorities are. We know the context. We can prioritize the patch, and we also have the remediations. So we can start knocking them off and just fixing a few of them, like the one path that led to the dandelion, could actually just prevent a huge. I mean, you might say the attackers could get in, but they might not be able to reach your crown jewels.
Great. So we
So
can have an outsized impact with minimal effort. I love it.
Absolutely.
yeah, I'd
Yeah, go
like
ahead,
to
David.
hit on a question. Well, I want to first of all remind everybody that we've got this scripted in such a way that daily the feed from ThreatWorks is brought into the Rocketgraph graph. So it's important to be timely. It's important to track things early. Early is very, very valuable. My question for Ketan is that there are like government entities who track CVEs, right? So how does your ThreatWorks feed relate to that source?
It's the same way you are getting this. I mean, Rocketgraph is getting this information in its database. ThreatWorks has a threat and vulnerability curation engine. We call it Attenuate. It's basically a completely automated, no human intervention required kind of a engine that surfaces threats and vulnerabilities from all these different databases, not just the vulnerability databases, but a ton of other sources. As you know, threats and vulnerabilities are published in different areas. I mean, there's vulnerability databases, vendor advisories, bulletin boards, security research organizations, GitHub. I mean, there's vulnerabilities and threats reported everywhere,
That's
right? So
great. You guys kind of stole my thunder a little bit. My next slide was going to talk about all this, but that's okay. You went ahead and talked about all the goodness.
Well,
Yeah,
I do have a follow-on question though.
go ahead.
Specifically, why do we not just hook up Rocketgraph to the federal government feed of CVEs and their tracking? Are you faster than they are? Do you have stuff earlier than they are?
Yeah, I mean, one of the things we saw in the NVD record for this particular CV, the 2025 CV, I mean, they're a government organization. They have, people who are doing this analysis for each and every CV that pops up. It's slow. I mean, they're always in a catch-up mode. As you saw, this CV was published sometime in September. They don't have a CVSS score for it. It's now kind of assumed that people who are really interested in this, the vendors or the security the security software providers will do the analysis themselves. So that's where we are lacking. I mean, just to depend on the government sources, the NVD, the mothership of all CVs, is not enough anymore. You have to scour the web, and there's plenty of information. There's people publishing new CVs on GitHub, right? I mean, think of all the open source vulnerabilities. Some of them don't even get disclosed as CVs. That's the state of affairs there. So we have to have our eyes out on the World Wide Web of threats and vulnerabilities, and that's what we are doing. Just track every known source, making sure making sure it's believable, because there could be misinformation out there, but track every believable source for threats and vulnerabilities in an automated fashion.
Well, this is great. This is I like to use metaphors a lot. This sounds like a peanut butter and chocolate scenario to me. Chocolate's pretty good on its own. Peanut butter is not too bad. Chocolate and peanut butter together make a Reese's peanut butter cup, which is one of my favorites. I'm hearing that you've got your core competence, Ketan. You do it well. You've got a lot of inputs. You've got a framework for doing it. We've got a great graph engine. More about that later. Plenty on our website about it. Scale's great, ingest great, a lot of AI incorporated into the experience. I hear two best of breed solutions that play together. Is that what I'm hearing right?
I would say so. Yes. I mean, this is like I said, this is a different perspective on how this data can be used. Traditionally, we have been looking at this purely from, scan reports and, large spreadsheets of things to do for, security operators and, IT operators, right? They have their own list of things in terms of patching and remediations to do. We are putting this in a different context altogether. We are really bringing the power of the graph here and saying, yes, we know you have like 10,000 vulnerabilities to address, but here are the real paths that could lead to a breach, a serious breach. And hey, why don't you look at them and prioritize it that way? So
Great.
it's a completely different way to look at this information.
Great, thank you. So let's get back to the flow, because I've seen some questions come in Q&A, and there's a couple that I think are pretty interesting stuff we really ought to discuss as opposed to a yes, no. So let me move it forward a little bit. So let's go to the Q&A period. I'm gonna hand it to Lisa now, who's been collecting questions from you all, and let's let Lisa bring up some of the questions that we've had come in. Lisa, please take it away.
All right, thank you, Walt. Good morning, good afternoon, and possibly good evening to everyone on the call. We have some really interesting questions that have come in, and I'm just going to start reading them off. And hopefully, we can have an interactive conversation. You can even continue to comment on the Q&A if you want to discuss more and react to the answers. So, the first question is from Jared. If our organization is already using ASM tools, would this solution complement, or do they need to be replaced?
So I'll give my initial thoughts, and then I'm going to let Ketan and David express their thoughts on this as well. The answer is, I'm sure we can make something work. The devil's always in the details. So it would really be a case of understanding what you're doing today, what the solution is, what the scope of it is there any white space or gaps, and what's the appropriate solution for you. Let me let Ketan and David express their respective opinions.
Yeah, I agree with you, Ward. I mean, both these solutions are bringing some unique value there to the table, right? And like this is some of the parts that is more valuable. I mean, are those parts individually, can we replace something with something else? Of course we can. it might not be the same result. It might not be the same impact that you expect. This is all about being proactive and being effective across the attack surface. Now I know there are some tools which do external attack surface management versus I mean there's a distinction being made there. I don't see why that needs to be there. Your attack surface is your attack surface, whether it's external or internal. Now, having said that, there is possible for other combinations of solutions to achieve the same thing. I would say that this is probably the best that is out there today, and what we're bringing to you.
Thanks, Ketan. David, what do you think?
Well, first of all, I think that a graph solution is maybe newer to the ASM field than the more traditional ASM tools. I think it's important to understand whether or not you can just bring in some new tools and try them out in your existing ASM workloads within an enterprise, or do you have to replace in order to try us out? And I think that's a big distinction. And I don't see that there would be any need to rip and replace, but just augment for a while and see how it goes. Um, that's my 2 cents. I think it's really important that we allow supplementing and just helping out the enterprises, right?
Thank you, folks.
Excellent.
So let me jump one more. I'll have a call to action here too. If you're interested in follow up based on what you hear today, I'm going to give you information at the end of this after this slide to how you can let us know. We're happy to follow up and have more conversations. So please go ahead, Lisa.
So Jared had a follow-up question. How do you handle extremely large asset inventories, like tens of thousands of assets?
Yeah,
I think we should let our respective folks answer because I know Ketan's going to have his domain and David's going to have his. And I see David smiling because he loves talking about this
I
stuff.
do.
yeah. Yeah. So in terms of the scale, this is an attack surface management, the ThreatWorx side of things. We are designed to handle, the enterprise level load. So we're okay. I'm sure, David will add color to what the graph can do, and they can do much better. But in terms of being able to manage a typical enterprise attack surface, yes, ThreatWorx is more than capable of handling it.
Yeah. So from the graph perspective, tens of thousands we think of as tiny. And I know that in this domain of 10,000 assets, that's not necessarily tiny. Um, but if you start thinking about all the different CVEs, the malware families, and all the relationships among the 10,000 assets, that graph structure grows pretty quickly in terms of just the number of relationships. But still, we were built specifically for high scale with Rocketgraph, and so we routinely run a billion edges, not just 10,000 or a million edges. That's still, kind of like real-time responses, usually.
That's great. And David, correct me if I'm wrong. We talk about this a lot, and I don't think we talk much about Rocketgraph today, but we're designed for interactive real time, right? I mean, that's what the high performance compute aspects of the product are all about.
Yeah, I mean, if you ask a question of a graph and you've got a significantly larger graph, I mean, these are provably computationally hard problems to search for patterns in a graph.
But we
And
have
so
patents to speed this up.
we do have some patents to speed this up, but it's still computationally hard. And what that means is you can ask a question and have it run for, 3 days. That's a long time to wait for an answer. Uh, Sorry, but if you try that same thing with other graph products, you might not finish within 3 months. Um, Again, we were built for that scale, but that's not the interactivity that we're talking about here. If we get a change in risk scores or some new exploit is happening for the malware using CVEs and things have changed, you want to mitigate, you want to react to that today, not wait for a very long time. So the reason why high performance is so important in graph is that you need the answer before it's too late. And this is a classic example of needing the answer before it's too late, before the breach actually happens.
Thank you, David.
Mhm.
Lisa, any more questions out there?
Yep, we do. We have quite a few. There's a long one. It's from Ugur. When an LLM agent is used to query an internal ASM graph or creations of scripts according to assets or asset information, what specific technical controls must be implemented to prevent a successful indirect prompt injection from causing the LLM to exfiltrate confidential asset data or system prompts rather than the basic input validation?
David's going to love this one. This is all
Yeah,
about
I
the way we
see
handle
David
AI.
smiling.
We have a pending patent on this one, so
All
I'll let
right,
David talk about
class.
that.
The professor is here.
Yeah, our implementation today will never allow any of the data parts of the graph to go to the LLM. The LLM will never see it. So the question about so there's no way to exfiltrate data through the LLM itself. I mean, data privacy and permissions is really, really important to the three-letter agencies that we're trying to cater to. But data privacy is as important to all enterprises. So we take that very, very seriously. We have the concept of having the graph running. Let's imagine it running within the enterprise network, because you don't want your data to leave your enterprise, and you are trying to use this mission control to ask questions about your data. The data will actually never leave the enterprise. What happens is that the answer can be shown on a web browser. And if an enterprise doesn't even want the web browser to look at data if it's outside the network, that enterprise can make those kinds of configuration requirements that you be inside the network before you connect to this mission control. So there's lots of different levels of permissions and tracking that can be done. Uh, that's our current position, though, is that we never share anything with the LLM, and all of the answers come back to the system running the browser. It's not possible to send it anywhere else.
I'll just add the ThreatWorks color to it. In terms of generating the patch scripts and the remediations, it's the same thing. The public information that we have about vulnerabilities and advisories and patches, that's all known. So all we are asking the LLM is to synthesize some scripts for us, and there's no proprietary confidential asset related information that is related to the LLM. Um, and so we take care of that. Also, our architecture is such that all of this information, in fact, the whole scanner, the console that you just saw, uh, can be hosted within your VPC. So none of this goes out. I mean, this we could just piggyback off your Azure, LLM factory if you have one, or the AI factory that Azure supplies. We could piggyback off of that. So none of this will ever even leave your enterprise. Although we are SaaS, we combine the best of SaaS with the best of having this on sort of closer to on-prem. Your discoveries are all local, your assessments are all local, and your patch generation scripts, even if they go out to an LLM, will not have any confidential context.
Thanks. Great responses and great question. We're about 6 minutes before the hour, and I do have a call to action I'm going to talk through. So maybe we can, Lisa, maybe we could do one or two more questions.
Yeah.
Do you have any other stuff?
Yeah, there's one question. There are two more, and I do think that they're worth discussing. So Jared was really appreciative of the detailed answer that everybody provided, and he wants to know how quickly can we deploy this solution, and what does onboarding look like for a typical enterprise?
Sure. So there's a couple of moving parts there, Jared. I'll give you my thoughts and let Ketan and David talk respectively. Obviously we've got some moving parts here, right? We have depending on if you're going to try out ThreatWorx with this solution, there's that. There's Rocketgraph. I've done videos on Rocketgraph. We use a containerized solution right now. You can get up and running in about 5 minutes on your machine. That's not a server, but The point is you can get it up and running and test it out and try it quickly. The joint solution depends again on, are we building something that's going to say take ThreatWorx data and yours and supplement the two and then build the graph, or are we taking straight up ThreatWorx, or are we taking your straight system today? Really depends. What we'd like to do is we'd like to have a follow-up conversation with you. So if you want, what we'll do is I'll follow up with you after. Let's schedule a time when we can have a conversation and figure out what makes sense for you. David, Ketan, any separate thoughts on that?
Yeah, so ThreatWorx deploys, like I said, as a as a flexible SaaS, so we could host it within your VPC. It's up and running, for you in a matter of minutes. Again, discovery is something that we need to, sort of schedule. It's a scanner. I mean, it needs to look into your enterprise. You have to do the things that you need to do in order to make it look at your attack surface. Once that is done, this is all automated. Data just flows from your attack surface into the ThreatWorx engine. Magic happens there, and then this data is then pulled into Rocketgraph, which may be sitting next to ThreatWorx in there. And you see what you saw here today, the blast radius of all your and all the attack paths. So I mean, this could be accomplished in a very, very short time. If you are interested, and we can, like Ward said, we can have a follow-up on this. We should have a follow-up.
Thanks, Ketan. David, any thoughts? I know we got to build a knowledge graph, but deployment to Rocketgraph is pretty easy, right?
That's right. Yeah, your answer, Walt, I think was very sufficient for Rocketgraph. We can move on. Yeah.
Okay, great. Lisa, what's our last question in the queue?
I like this last one. Can one engage in counterattack to attacking entity, kind of the quote inverse problem in cybersecurity?
Well, that sounds like right up Ketan's alley to
Yeah.
me.
Yeah. So yes, the short answer is, of course, yes, we can. I mean, we have enough information to sort of do this counterattack. It would basically be, what kind of a counterattack do you want to say? Do you want to do, block these external websites that might be, beacons, or sort of these places where the exfiltration might be happening? Well, that's one way to look at it. You could also, do some early reporting. If you're seeing these vulnerabilities, if you're seeing these IOCs within your enterprise, within your networks, you could go the law enforcement way, report. I mean, at least on the US side, this is taken very seriously, and these websites could be shut down very, very, or these external malware hosting websites could be shut down very, very easily. So there are different ways to look at this. What I believe more in is being proactive. You should not be in a situation where the attackers are even within your network. That's when things are really going sideways for you. This is all about identifying these potential paths before, and then it becomes a whole lot easier. Just patching these few systems will protect you, will give you the sort of hygiene that you need. And so you don't have to do this, sort of firefighting and, counterattacking too much in the sense.
Okay. Thank you, Ketan. Lisa, if there are no more questions, maybe I can talk about a call to action. What do you think?
I think it's perfect.
All right. So I know folks probably have to get to the next meeting. First of all, we want to thank you all for investing an hour with us today. It's a busy world. We're small vendors, and we're glad to have you here. We hope you've got value. Follow up. I always like to give people an option. If you want to learn more, if you want to do stuff, that's fine. Simple. Email me. My email address is very, very complicated. It's walt@rocketgraph.com. Please email me. Let me know you want to talk more. We've got lots of assets we can share. In the interest of time today, we didn't share a lot of that. Please let me know. We're happy to talk more with you. So in conclusion, I want to thank you all again for joining us today. Thanks for the lively questions. It was good stuff. We love doing this, and we're looking forward to doing more. Stay tuned for the calendar for 2026 of all the good stuff we've got coming. Thank you very much.
Thank you.
Thank you.